All right, so in this lesson, we're going to learn how to solve quadratic equations by completing the square. We're going to look at two problems. Now, these two problems are going to involve fractions, so just keep that in mind. There were other lessons that I provided to you that did not involve fractions, but these two will, because you do have to learn how to deal with fractions. So one of the resources that you're going to need is this resource, and so completing the square, and it says using the square root property, which you've learned previously, it is possible to solve any quadratic equation that's written in the form x plus b squared equals c. And in order to set up these problems in the correct form, you will need to recognize that x plus b, that expression that's on the left-hand side, is a perfect square. It was a perfect square trinomial. And then to turn the quadratic equation, this quadratic equation here, into one that can be solved using the square root property, we're going to use the following steps. All right, so remember, given any quadratic equation that's written in general form or standard form, we can change it into a quadratic equation that we can easily use the square root property with. So this is going to involve completing the square. All right, so step one, if a, now remember a is a coefficient of x squared. So if a is not equal to 1, then we're going to divide both sides by a, by that coefficient. But notice that in this problem, the coefficient of x squared is 1 right here. So that's understood to be a 1. Step 2, we're going to rewrite the equation so that both terms containing the variables are on one side of the equation and the constant is on the other. So if I look at number 1, notice that all the terms on the left-hand side. So ax squared plus bx plus c. What we want to do is we want to bring this constant term to the other side. So this step will be this. X squared plus 7x is equal to 8. All right, so that's that step number 2 that you see here. Step number 3, and it's always going to be like this. It's always going to be where you're going to take half of the coefficient of x, and then you're going to square it. All right, so we're going to go back to our problem. So here's my x term right here. This is my x squared term. This is my x term. The coefficient of x that you see here is a positive 7. All right, so I'm going to go off to this time. I'm going to do this step. So step 3 says I take half of that coefficient of x. So in other words, I'm going to take the coefficient of x, which is 7. I'm going to take half of it. So I'm going to divide it by 2. Once I do that, then I'm going to take that expression here, that fraction, I'm going to square it. So 7 halves times 7 halves is 49 over 4. All right, so that's this step 3. So that's what I just did. Then we're going to add that number to both sides. So we're going to add the square to both sides. So once I square it, I'm going to add that number here, this right here, to both sides. So the way you're going to write it is going to be this. X squared plus 7x plus 49 fourths equals 8 plus 49 fourths. Okay? All right, so that's what we're going to have there. All right, now, step 5. One side should now be a perfect square trinomial. So that's what we're talked about right here. So one side should now be a perfect square trinomial. So you want to write it as a square of a binomial. So that's going to be this trinomial right here. So if you're doing this step correctly, then this right here will always be a perfect square trinomial. So that means that you can factor this as a binomial squared. All right, so let's think about this. So this says that if I'm doing this correctly, this says that this trinomial is always going to be a perfect square trinomial. All right, so remember what that means. That means that when I factor, I'm going to rewrite it over so I can show you. So when I factor this perfect square trinomial right here into two binomials, then what that means is that this binomial and this binomial are going to be exactly the same. So let's go ahead and factor this. So this one's easy, the x squared, so it'll be x times x. Now, whenever you square this and you add it to both sides, this will always be a plus symbol right here. It will always be addition. All right, so keep that in mind. So that means then that these signs in here are going to be the same, and they're always going to be that middle sign here. So I know that now it's going to be x plus, x plus. And then the next part's easy. So what two numbers, or what number rather, multiplied by itself will give you 49 halves. So let's think of 49. What number times itself is 49? Well, the answer is 7 in it. Okay, so I'm going to say 7, 7, and then 4 rather. What number times itself is 4? Well, 2. So this right here becomes 7 halves. So, and then also notice, I'm sorry, I forgot to put a 2 here. So 7 halves. Notice that the 7 halves comes from here. See that? So now I can write this as x plus 7 halves squared. And that's going to equal, now, I've got to now do some work over here. I've got to add these two fractions. Well, remember you have access to a scientific calculator right here. So let's go ahead and do that. So all you really need to do is just say 8 plus 49 divided by 4 equals, all right, you get this decimal, right? Now, most of you know, and I'm going to do that here, most of you, or all of you rather, I should say, know that 20.25 in words means 20 and 25th hundredths, right? And then 25 hundredths reduced is 1/4, so that's 20 and 1/4. And then you want to rewrite this mixed number to an improper fraction. So that's what you want to put here. You want to put that fraction, that improper fraction. So you're going to say 4 times 20 is 80. 80 plus 1 is 81. So you get 81/4. So that goes here, 81/4. Now, if you did not recognize what I just said, hopefully you did, but if you didn't, then all you got to do is this. So you remember you want to change this to a mixed number. So that mixed number, to get that mixed number, see right here where it says FTD, just look at your calculator. You're going to see that FTD and it's in blue. To get that, you got to press second and then press that PRB button right here. And then right here you see fractions to decimal, decimal to fraction. So we're going to press equal, and now you get 21/4, which is what you saw here. And then all you have to do is just take that and change it to an improper fraction. All right, so that's the next step. All right, so now the final step, step 6, is to use the square root property. So you learned about the square root property in a previous lesson. So remember, you want to solve for x. So let me go ahead and just rewrite this over. So you want to solve for x, and that's what we have. So you're going to take the square root of both sides. Remember the square root property? We're going to take the square root of both sides. Now remember, when you take the square root of both sides, don't forget that plus or minus notation. And then the square and the square root undo each other, so we get x plus 7 halves is equal to plus or minus, and it turns out in this case that the square root of 81, well, 81 and 4 are perfect squares. So the square root of 81 is 9, and the square root of 4 is 2. Now, remember we talked about this in previous lessons, whether it's online or face-to-face, that this right here, when I took the square root, that number is a rational number. So we're dealing with rational numbers here. So my solutions are rational numbers. Remember, when we talked about that, we want to actually find out what those two rational numbers are, or the rational solutions are. So we're going to split it apart. You're going to say x plus 7 halves equals 9 halves. Remember, plus or minus. And the other one is x plus 7 halves equals a negative 9 halves. Oops, 9 halves. And then you're going to get x by itself, so you're going to subtract 7 halves from both sides, just like this. And then combining like terms, this is 0. 7 halves and a negative 7 halves is 0. You get x equal, you have 9 halves minus 7 halves. Well, 9 halves minus 7 halves is, remember, 9 minus 7 is 2. So that's 2 halves, which is 1. So one of your solutions is x equal 1. Okay, let's go to the next one. So to get x by itself, we're going to subtract 7 halves from both sides. So I get x equal a negative 9 halves plus a negative 7 halves. That's what this means right here. A negative 9 halves plus a negative 7 halves is a negative, 16 halves? And a negative 16 halves is a negative 8. So my other solution is x equals a negative 8. And so that's it. So those are your two solutions. And notice that I did this by completing the square. All right, so notice the steps. All right, let's look at number 2. So finally, number 2, we're just going to do 2 of them. So finally, number 2, we have this equation. So let's look at this one. All right, so number 2. All right, so number 2, this is the equation. We have 3x squared minus 5x minus 7, plus 7. Let me make it minus 7, minus 7 equals 3. All right, so 3x squared minus 5x minus 7 equals 3. Okay, now let's go back to our steps. So step 1, if a, the coefficient of x squared, is not equal to 1, then we're going to divide both sides by a. All right, so notice coefficient of x squared is not 1, so we got to divide both sides by 3. Now before we do that, here's what I would do first. I would go ahead and bring this constant to the other side. So let's go ahead and do that first. So we're going to add 7 to both sides. So I get 3x squared minus 5x equals 10. Now we're going to divide both sides by a, which in this case is 3. And so that's where I'm going to end up with some fractions. But that's okay. We know how to deal with fractions. All right, so you're going to do this. So let me go ahead and just rewrite it over here. All right, so then you're going to say this divided by 3, this divided by 3. So what you do to one side, you do to the other. And then I'm going to split it in separate fractions just so you understand what's happening. So 3x squared has to be divided by 3. A negative 5x has to be divided by 3. And 10 has to be divided by 3. And so now 3 divided by 3 is 1. So we get x squared minus 5/3 x equals 10 thirds. All right, so now next step. So the next step is to rewrite the equations. Okay, so I already did step 2. Step 3 now is to take half the coefficient of x and then we square it. Okay, so think about this. So the coefficient of x here is a negative 5/3. So I'm going to put that on the side. Okay, we've got to take half of it, so meaning divide by 2. Now remember, let's review something. I have a fraction divided by a fraction. So I can always change this division to multiplication. So that becomes the fraction in the numerator times the reciprocal of the fraction that's in the denominator. So the reciprocal of 2 is 1/2. Now I'm going to multiply those two fractions. A negative 5 times 1 is a negative 5. 3 times 2 is 6. So I get negative 5/6. Now remember, so I had to take half the coefficient of x. So I took the coefficient of x and I divided it by 2. And I changed the division to multiplication by multiplying by the reciprocal of the denominator. And then multiplying the numerators together, I get negative 5. Multiplying the denominators together, I get 6. Now remember, the next thing you got to do now is square it. So we're going to square this negative 5/6. So negative 5/6, remember, means this. Negative 5/6 times negative 5/6. Well, remember, a negative times a negative is a positive. So 5 times 5 is 25. 6 times 6 is 36. And that's what you add to both sides. So I'm going to add that to both sides now. So that was the next step. So step 4 is to add to both sides. So I get x squared minus 5/3 x plus 25 over 36 equals 10 thirds plus 25 divided by 36. Okay, now, if I'm doing this correctly, if I did all of this work right here correctly, then remember, this is now a perfect square trinomial. A perfect square trinomial, meaning that I should now be able to factor this as a binomial squared. That is going to be step 5. So step 5, one side should now be a perfect square trinomial, so you want to write it as a square of a binomial. So just like we did in the previous problem, let's think about this. Let's just do that on the side. Most of you at some point are not going to have to rewrite it. You can look at this right away and indicate what that binomial is. So we have x squared minus 5/3 x plus 25 over 36. All right, so let's go ahead and factor this to binomials. And those binomials have to be exactly the same. That's what makes this a perfect square trinomial. You can write it as a binomial squared. So x times x is x squared. And remember, this is always going to be plus right here if you're doing this correctly, because it did say, right? It did say add to both sides. And also when you do this, whenever you square that number, it's always going to be positive. So you see where it's negative right here. Negative times a negative is a positive. A positive times a positive is a positive. So it's always going to be positive right here. All right, now, so and the middle sign is going to take that middle, the two signs here are going to be the same. It's going to be that middle sign. So x minus, x minus. And then the rest is easy. You're asking yourself, well, what goes here? Well, what number times itself is 25 over 36? Well, let's think of 25. Now, hopefully by now you notice that the numerator and the denominator are perfect squares. They're always going to be like that because you're squaring it, right? You're squaring. So what times what is 25? Well, 5. What times what is 36? What times itself is 36? 6. And notice that that's what you see here, negative 5, 6. So 5, 6, 5, 6. And so that's going to go here. So that's going to be x minus 5, 6. Now, one of the places that confuses students or that gets students is this sign right here. Just make sure that that sign corresponds to this middle sign. So if that was plus, this will be plus, okay? And then that's going to equal, and, oh, and by the way, you can always check this, right, by foiling. All right, so let's just check it real quick. X times x is x squared. The outer, x times a negative 5, 6 is a negative 5, 6, x. The inner, negative 5, 6 times x is also a negative 5, 6, x. So the outer and the inner will always be the same, since that's a perfect square trinomial, since those two binomials are exactly the same. And a negative times a negative is a positive. 5 times 5 is 25. 6 times 6 is 36. And then negative 5, 6 and another negative 5, 6, right? Those are like terms right here. A negative 5 and negative 5 is a negative 10. And then divided by 6, you keep the denominator, and then reduce, you get negative 5/3, which is what you saw. Okay? All right. Now, for that one, use your calculator. You have access to your calculator. I'm going to go back and just remind you how to do this by hand. I should have done it in the first one, but we'll do it here. Okay. So we have 10, oops. So we have 10 divided by 3 plus 25 divided by 36. All right, so I have this let me make sure I did it correctly. 10 divided by 3. All right, so I have this decimal, right? Now, remember the previous one, it was easy to see, and let me just see if I can get back to it. It was easy to see that this decimal means 20 and 25 hundredths, and you could reduce the 25 hundredths, and you could easily get it. Here, it's not so simple, right? So what I would then do is just use your calculator. Second, PRB, and you want to change it to a fraction. So press equal, and you get this. So this right here is 4 and 1 divided by 36. But you want to change that now. You want to change that to an improper fraction. So remember how to do that. You're going to say 36 times 4 and then add the numerator. So you can say 4 times 36 equals, and then plus 1 equals 145. So this becomes 145, oops, let me do that here, 145 divided by 36. So that's going to go here. All right. Now let's just so let's suppose you didn't have access to your calculator, and you wanted to add these two fractions. Let's remind ourselves how to do that. All right. So we have to find the least common denominator, right? So the least common denominator of 3 and 36 is 36. That's the smallest number that 36 and 3 will go into. And always use the least. Makes things easier on yourself. The least common denominator is 36. So we're going to write two fractions with 36 as the denominator. Now, so we're writing equivalent fractions. 10/3 is equivalent to what fraction involving 36 as the denominator? So to get 36, I'm going to have to multiply 3 by 12, right? But what I do to the denominator, I've got to do to the numerator. So that's how you write equivalent fractions. You're going to multiply numerator and denominator by the same number, so that way you get that denominator you want. So notice 3 times 12 is 36. 12 times 10 is 120. And then over here, those two denominators are the same, right? So the numerators have to be the same. So 25 divided by 36 is equivalent to itself. And then when I add those two fractions, 120 plus 25 is 145 over 36. And so that's what you saw here. Okay, now remember the next step is to solve for x. So that's where we use the square root property. So let me go ahead and rewrite this over. And then you're going to take the square root of both sides. Don't forget the notation, plus or minus. The square and the square root will undo each other, so you get x minus 5/6 equals plus or minus. And I'm going to write this as the square root of 145 divided by the square root of 36. And we're going to simplify. All right. Square root of 36 is a perfect square. So that's going to be 6 in the denominator. So let me go ahead and rewrite this. So x minus 5/6 equals plus or minus the square root of 145 divided by 6. Now remember, you want to simplify the square root of 145 if you can. So let's think about that. Square root of 145. All right, now, so remember your perfect squares are 1, 4, 9, 16, 25, 36, 49, and so on, right? Oops, and so on. So let's think about 145. Now, so 1's a perfect square that goes into all numbers, so we're not even going to use 1. And then since this is an odd number, we're going to neglect all of the even perfect squares here. So let's look at 9. So is 145 divisible by 9? So let's think about that. 145, well, first of all, is 145 a perfect square? So that's what I would always check first, especially if this is a big number right here. So I would take the square root of that and see if I get a whole number. So the square root of, right here, square root of 145, let's see if that's a whole number. And it is not. So 145 is not a perfect square because I get a decimal. All right. And so right here, you see where you can see that 12? So really you want to check the perfect squares that are less than 12. See if any of those will go into 145. So we don't have to worry about 4 because 145 is even. Now let's do 9. 145 divided by 9 is a decimal. So 9 is not a perfect square, and I can stop. Right? I can stop at that point. Now, just want to show you something. So at some point, you need to kind of think like this. So I know that 5 will go into 145. So even though 5 is not a perfect square, let's look at that. 5 will go to 145. So 145 is 5 times 145 divided by 5. We're just looking at the factors of 5. 29, and 29 is a prime, and 5 is a prime, and that's it. So right away, you know that there are no perfect squares other than 1 that goes into either one of these. And so you cannot simplify the square root of 145. So that means we're almost done. So you just got to get x by itself. So you're going to add 5/6 to both sides. So this becomes x equals 5/6 plus or minus the square root of 145 divided by 6. That's one way to write the answer. Remember, there are two solutions though, right? See, a positive and a negative. The other way to write the answer is to write this as one fraction. So I wrote it as two fractions right here. So the other way is just to say this. 5/6, oops, sorry, let me redo that. 5 plus or minus the square root of 145, all divided by 6. Just make sure you're going from here to here so you don't lose any points. What some students do, when they write it in its compact form right here, they write it so quickly and they forget to write it correctly. See, that's incorrect. Because you got to remember the whole thing is being divided by 6. The way it's written is you're saying square root of 145 is the only thing to be divided by 6. So be careful. Make sure everything you write is mathematically correct. All right? Okay. And then another way to write this, and you may have to do this in MyLab or some other platform, is to write as two separate solutions. So you're going to say x equal 5 plus the square root of 145 divided by 6. Notice all that's being divided by 6. And the other one is 5 minus the square root of 145 divided by 6. And that's it. All right, so that is completing the square. So that's what it involves. It is very helpful to have these steps in front of you. At some point, you won't need them anymore. This idea of completing the square is going to come back when we talk about circles. So at some point, you're gonna write equations of circles in standard form, and that's going to involve completing the square. All right, so that is it. So that is the lesson on solving quadratic equations by completing the square.